Welcome to MMT Chats. This episode is brought to you by ISCAR with new ideas for machining intelligently.
I'm Christina Fugis, Editorial Director with Mold Making Technology. My guests today are from Action Mold and Machining in Grand Rapids, Michigan. We have Additive Manufacturing Manager Greg Nemechek and Matt Duffy, Marketing and Advanced Development for AM. And we are going to discuss additive manufacturing education and ROI. And that's because both of them strongly believe that education and ROI go hand in hand, because without a solid understanding of additive manufacturing's value, you can't possibly understand the true ROI of the new tooling. So hello, Greg and Matt.
Hi, Christina.
So what are some, Matt, can you talk about any physical and social barriers that you think maybe Action didn't encounter, but that people should be aware of?
Yeah, so I mean, a big part of it, and in terms of adopting it, is the lack of education within a business, whether it's a 10,000 person aerospace company or a 40-person mold shop. Is they see an article that made it into the news somewhere of, oh, this powder supplier blew up. But
Right.
okay, there were a lot of contributing factors to it. I've been dealing with the reactive materials for 7 years, and I've never had any ignition at all. Because if you follow common sense is the biggest one, then you're going to be safe. So I try to instill that whenever I was talking to companies. But for the most part, there isn't much that's dangerous about the technology as much as a lot of groups say there's all these things. You got to take a step back and say, okay, I'm going to proceed with caution. You got to involve the right people. You got to make sure that your fire department is aware of what you're doing and how you're going to do it, so that they're safe. If something catastrophic were to happen, they can come in and know how to handle it, right? So there's a big, I don't want to say a barrier to bringing the technology in from a approval standpoint, but I have run into places where, oh, you're going to generate this, that we can't allow that in our city. We're not going to allow you to buy the technology because it's not safe to run here. So I would spend weeks talking to fire marshals, to building inspectors, anything like that, saying, no, you're reading this, but here's in reality what is actually going to happen, right? And once we can get past that barrier, then it was adopted a lot easier. But inside a company, there were places I've been to, some facilities that they'd knock on the door, lean in and say, is it safe to come in? If you're doing it right, it's always safe to come into the room, right, Greg? Like, you have people pop in and out all the time, and unless there's certain times where you say, no, don't come in. Yep. When I was at Runner Show, we had a sign that we'd put on the door saying, don't come in because we're doing a big clean down job. We're going to have powder around. We're going to have this, that, or the other. But that's maybe 5% of your time in terms of the whole process. So getting that education out there, but then also being able to, like, I would walk around with part after part. I'd carry a 50-pound plate across the whole Renishaw office, showing a part off that here's what we just did for this customer, to say from the machine tool group, here's a customer that you guys are already talking to, that here's the part we printed for them and everything like that. Or I'd be talking to the CMM group to say, how can we measure this to make sure we're doing it right? Stuff like that. And got a little bit of excitement going that way. But they go a little bit hand in hand. If someone hears that there's a barrier to bringing it in because they heard the fire marshal say, well, no, it's not safe, or you need to wear this kind of respirator all the time when you're around it, they're going to be a little more leery of the technology. Right? And you get,
of course,
depending on who you are listening to in terms of I guess social media is probably the best outlet that people are sharing information on right now for AM. It's, you listen to one place, if they're a safety focused group, they're going to show, here's the risks and why you need to go this approach. But I had customers that they bought the machines, at a university, bought 3 machines with funding they had. So it was like $1.2 million worth of machines. And then by the time we went through the ancillary stuff like an EDM, CNC, and the other bits and pieces that go with it, there was another $500,000.
Yep.
And then they said, where are we going to put it? They found a room. They couldn't get approval because it was a basement or next to students or whatever it was. Then they found another area that they were going to have to build an area inside a big building. And the building company said it's going to cost you $1.5 million to retrofit this facility. I said, and when they came back, because I was trying to get the installation of the machine scheduled, and said, well, what's the holdup? Oh, it's this. And I said, okay, can we talk all of us together so everybody's on the same page and understands what this actually means? And then over a half-hour conversation, we cut off $500,000 worth of building work, just in a half-hour conversation, because it was needing to educate the building engineers how the technology actually worked versus how they read in between the lines without understanding the technology of what was written down on this piece of paper. So there's a lot of education that needs to be brought in across the board, from contractors for doing a building, fire marshals, safety inspections, but then in the shops is almost the least in terms of getting that adoption.
Okay.
It's getting buy-in from everybody that has to approve you doing it.
Right.
So a smaller shop is great for that.
I wasn't even expecting you to go down that road when it came to barriers, but that is, that could be petrifying to a company to want to get involved if that's what's out there. Wow. So that's good to know. So what is a word of advice if you're going down that road, hearing all that? What is the first step to make sure you have the right information? You're going to go about it right, if safety's not as much of an issue as they think it is.
Well, I think for us, for Action Mold, it was making sure you had somebody from the OEM who's willing to work with you. We had Matt, and when I started looking at all the changes we needed to make to our building, I would just call him and I say, "Do we need this?" He'd say, "No." He said, you can just put, for example, the floor. My floor is all concrete. And he said, just put an anti-static mat in front of your machine.
Yeah.
You don't need to spend $4,000 to cover an entire floor with an an anti-static flooring. He said, just put a mat in front of the machine. So $75 later, you're got that part taken care of. But if you don't know and you don't ask,
Or you don't know what to ask.
Right.
That's very valuable. Okay, go ahead.
And I think with that, there's you have the level that companies that are paid to advise on the safety are going to set the bar, way up here, so that if you do 80% of what they said, you're still here, you're still more than safe, when the safety level is right here. They want to build in that safety factor. And I was always much more supportive, saying, let's aim for here, so that if you come a little bit short, you're, a little bit short, but you're still safe compared to down here. And this is the danger level. But I had a number of customers that they didn't want to listen to that end, but then the sales end of the OEM says, no, you don't need anything. Just put it right next to your EDM. And I would shake my head and say, no, because now you're just going to create a problem for the printing. So no, we got to do this separate. We got to think it through. But it was, for me, I was always very honest and transparent with any of the customers that I was working with, to say, here's the reality of what you need for your application, because what you need for aerospace or medical, just from a regulation standpoint, is different than what you need in a mold shop, right?
Exactly.
Because you have different levels of monitoring, of validations, or whatever it is. But also, just if you have questions, go to somebody that's already adopted it. And if they're, like for us, we're as transparent as we can be. If you said, what did it take to get, facility wise to bring the technology in, then we'll share it. There's a lot of companies that are willing to share that story. They may not share what all they're doing with the printer, but they're willing to share the story of how they brought it in, what they ran into. So not being afraid to ask users is another path that you can say, what did you actually do? Especially if they're local, because they had to follow probably the same set of rules that you're going to have to follow.
True.
So asking a company in California versus asking a company in the middle of Texas, very different regulations.
Yeah, very different. Yeah.
Right. And asking the company in California for trying to install it in Texas you're going to be way over the top in one aspect or another. But understanding what it is, but making sure that you're applying common sense and thinking through the whole thing is the biggest key.
So talking about the facility, let's get into the equipment because I know we've talked about, and I know this is something that I've battled with people. You're not just buying a printer or a printing system and you're done. I mean, there's a value to, you have to understand how much other equipment and expertise is necessary, right, to do it right. And then it's also, according to you guys, it's important for that mold maker who gets into that, or it's advantageous to have the capabilities to offer support beyond just printing, just the additive manufacturing. So can Matt and or Greg talk about that a little bit?
Yeah, that, you know, just to get the equipment into the building, you know, the printer is just the first step, right? Matt already mentioned there's other equipment, there's ancillary equipment. Well, it depends on what you're doing. If you're printing end use parts and when you get them out of the printer, you clean them, you prep them. And if you're going to send them out, you might need other equipment than you do if you're doing, for example, like what we do, where we're going to take what's been printed and then we're going to machine it. You know, we get it out of the machine, we depowder it. We might run it through a hot tank to make sure we get a sonic parts cleaner to make sure we get all the powder out of the chambers, out of the internals. And then it goes to stress relieve and it goes into the CNC department and we cut it. We don't need to bead blast it. We don't need to do a bunch of this other stuff to it to prepare it because it's all good. All the surfaces are going to get machined anyways. So, you know, there was a lot of equipment that initially we thought we needed to buy, but as we went through it step by step, we said, no, we don't need all this different stuff. And it ended up being a lot simpler than what we thought it was going to be.
Agreed, Matt?
Yeah, I mean, there's equipment that falls between printing and finishing. So a bead blast, but you got to make sure that the collection system for a bead blast, if you're doing reactive materials, is safe, right? Because you're sparking parts off basically. When you hit silicon carbide onto an aluminum part, you're going to have aluminum powder flying off of it, and that's reactive. But if you're not going to bead blast everything, you can go from one step to the other, then you can save all of that, which is space, money, time, all of that. But there's a lot once you go past that cleaning stage, is probably the best way to say it, is whether you're depowdering, bead blasting, whatever it is, you're trying to clean up the surface of your part. Yep. But then you got to do your real finishing. And outside of possibly some medical applications, there isn't really any production AM part that's not going to need some form of machining, EDM, polishing, something to make it an end use part.
Yep.
And there's a lot of times that you'll have a company that they'll buy the AM equipment. They might be a 5-person company, but they're going to get in, they're only going to buy the printer and the stuff that they absolutely need to make a printed part. And then they're going to say, oh, yeah, I guess I can't deliver this part finished. I can't say I finished your part until it's machined to have all the mating surfaces right. It's machined to tolerance, whatever it may be. And they didn't budget for a CNC. So now they're going to outsource that, which then means their parts are going to cost more and everything like that. Where when you look at even a small molding shop, they've got all of that capability already. Yep. And when I look at some customers, it was, okay, I need to buy the printer, the sieve, vacuum, downdraft table, parts washer, EDM, CNC, surface grinder, and a CMM, and because
right.
they're trying, you have to actually make a manufacturing facility.
Right.
Printing isn't an end all be all. It's not, I don't foresee it being that in any of our lifetimes of making something to outperform a machine surface.
Yep.
There's too many variables that are for another time.
Yeah,
but
that's another discussion.
It is.
You need to have all this capability. You need to understand manufacturing to understand how to make an end part. And shops that are already established have all of that. They have the equipment, but they also have the knowledge on how to use it. And
that's a great point.
That's a big piece for companies that are just, they might buy the equipment, they might buy the CNC when they're just starting, but they're college graduates that have exposure to additive, but they don't know how to run a CNC. They don't know what an EDM even is. They think it's just, oh, it's just a bandsaw, I'm going to cut a part off. Why don't I just buy a bandsaw? You can, but it depends on what you're trying to do.
Yeah.
And EDM is a great
variables,
tool.
Right.
Right.
Yeah.
All right, so let's get into the ROI of additive manufacturing, because you've said to me that additive in mold making is the quickest return on investment. So let's get into that. Greg, do you want to start?
Sure. Really, simply put, the return on investment it's not going to be found in your tooling, in building your tooling. The return on investment for additive manufacturing and injection molding is when that mold goes in the molding machine, and you're able to reduce cycle time, and you're able to reduce scrap. That's where the real savings is. Where the return on investment is for the mold maker is in sales of more tools, because you're now producing tools that run better and faster. So hopefully you get more sales. And then that's where we're going with this.
And Matt, you've spoken about mold making as compared to other industries, about the whole requalification, right? So can you talk about that a little bit?
Yeah, so a lot of the ROI is, when you're looking at other industries, is what's the ROI on the machine? How soon can they recoup the cost of the machine? And it really depends on what they're needing to make. If they're making tools, then you don't necessarily have to go through qualifying the performance of the metal that you're printing. But if you're looking at printing a turbine blade, or you're looking at printing an actuator or a manifold or a dental implant, a hip implant, anything like that, you spend more time printing blocks, little cubes that are, not even a ½ inch by ½ inch by ½ inch, and
Right.
tensile bars that are ½ inch diameter by 3 inches tall. You're spending months building and printing and then machining and testing those before you've even made it to printing a geometry. And then you go through and repeat a lot of that testing again. So I've had some customers say that for a new part can be well over $500,000 in qualifications. If it's a flight critical part or it's a medical critical, if it's a implantable part, can be a huge cost until you've proven your process enough.
Yeah.
But then you change and do a new part. Now you need to repeat that qualification. Or if you change your machine, you need to repeat that qualification. For molding, it really doesn't matter what machine you're using, as long as you can get a dense part with the surface finish that you want in the same material. It could be a Renishaw machine, an EOS machine, an SLM machine, because you're not needing to requalify
Got it.
with anything like that.
Yep.
So it's a time savings, but it's also a huge cost savings in terms of the ROI on the machine returning, saying I can make a usable part much quicker. I'm not saying you're going to make you're not going to make money on the first part you print, because there is a learning curve, but there's a learning curve regardless of the industry. You need to learn the machine, whether you're tooling, medical, aerospace,
True.
automotive, industrial. You have 6 months that you need to really learn the technology, learn the machine, understand its quirks, its behaviors, everything like that. And then you can start looking, and at that point is when you might start your sample builds for qualification, where at that point now tooling, we can start saying we're going to run this tool in our own press.
Exactly.
And the ability that Action has always had of being able to design, print, machine, measure, polish, and run gives them the ability that they can build their understanding of the process and how a printed tool is going to behave, which is a phrase that I got from my old manager at Renishaw was, "We know because we do." That was the mentality he wanted me to have.
I like that.
We're selling a printer, but he wanted me to be able to support a customer all the way through measurement of a part. And it was, I had to know because I already did it. So if you're building something that's almost the entire height of the machine, I needed to run a part like that, understand how the machine was going to behave, if it's going to behave differently, how I'm going to clean it, and likely break the machine the first time so that I could teach a customer how not to break the machine.
Mhm.
And continue that kind of mentality. That's once I followed that all the way through when I was at EWI and working with Greg, he's kind of adopted that same, it aligned with his mentality already. He doesn't want to offer something without having done it already.
Exactly. And again,
Right.
that seems like common sense, right? You're going to know what you do. So
Right.
with all that being said, and knowing that additive manufacturing is going to continue to advance, and that Action Mold and Machining is at heart a mold builder, right? So when you look at that industry or that role, how do you define the future mold builder? What's the skill sets? What are the qualities and characteristics that individual is going to be in the future when it comes with additive manufacturing in mind?
Well, the way I think it's going to change is primarily the people that are coming up, the guys like Zach, these young guys that are coming into the trade, they're gonna be designing and building tools, but they're gonna be learning to do it with additive already in mind. For us right now, we're learning the technology, we're seeing what the benefits are, and we're going and retrofitting some of our existing tooling. For the next generation coming up, those guys they're going to be, additive is just going to be another tool in the toolbox that's going to help them produce a better tool. And, that's where I see the new shops going. They're going to have this technology is going to be in the shops in the future. And it's not just going to be a few. I think the majority of your shops are going to have some kind of additive manufacturing capability on their own.
How about you, Matt?
I think like Greg said, in the future, that's what we'll see is you're going to have kind of the next generation. Everybody that's in that next generation is already kind of in the engineering end thinking, can I print this part? I've talked with companies that their prototyping group said, can you print? I just need this printed and it's a cube. And we're like, I can buy that off the shelf over here. Well, no, I just want it printed. Well, no. But they're already thinking, I want to print.
Yep.
And I think you're going to see that carry over to mold making. But until you get to that point, there's the people that you need to find and either bring in or encourage to pursue it are the people like Greg that were hungry to learn something new. You need to have people that have an open mind that want to say, yeah, I don't want to just kind of sit back and let my time go, keep doing things the way I have been. I want to do something new. I want to learn something and keep pushing that, because the AM industry has a huge change every 6 months to 12 months.
At least,
you look even during 2020 when there was so much shut down, there were still, leaps in the technology. You went from a 4 laser machine being the kind of top of the line, fastest machine out there to now what's being offered is in some cases 10 and 12 laser machines. So your throughput's through the roof, but you don't necessarily have people that are wanting to pursue that. If they're later in their career, they're just saying, okay, we can keep kind of going. But when you get somebody that's hungry like Greg, it brought him back into industry, and it gets exciting, and you need to find those people. And unfortunately, they seem to be harder and harder to find.
It is a technology that can really help advance manufacturing just itself, whether it's mold making, tool, whatever it is, it's just pushing it forward.
Absolutely.
Before I let you go, do you ever encounter though where there are people that are going to be jumping to that too quickly, where there's still that place for a traditional method of making something is just the better option? So it's oversold and it's overused. So sometimes you're going to tell that next generation, whoa, slow down. This is still the tried and true and most cost-effective way to do it.
Yeah, that's absolutely the truth. In fact, we have one new customer that came to us because we had additive, and they wanted to print these little molds. And I looked at it and I said, okay. And so I took one of their tools and I put conformal cooling in it and I sent it to him, and he said, well, what are all those lines in there for? And I said, well, you want to print this, right? So I'm trying to get some cooling into your inserts the way you would cool them. And he said, well, we don't run any cooling in our tools. I said, we don't need it. And I said, well, then why do you want me to print this? He said, well, I thought it would be faster. And I said, no. And there was a little bit of a communication. There was a little bit of a communication breakdown between the engineer here that was giving the information to me and asking me to do something in our customer. But the point was, he was expecting us to just print this block that I can go out on the shop floor and grab a piece of P20 and go to work, and in a couple of days have a finished block with a cavity burned in it, And but we ended up building tools for them because they came to us for the additive side, but we showed them I can do it cheaper, just like traditionally. And
you educated them. Educated them.
But at the same time, now they're sending us molds that do have cooling in them. I'm quoting one now. So it's going to be interesting to see where that relationship, how that grows. But yes, you do get people that come and they want things to be printed that you can easily manufacture using traditional methods.
Yep.
So
just like with a lot of tools, there's a lot of different pieces to it. So there's areas of the tool that don't need to be printed. If you're like Rick said, if there's no cooling there, if it's just something to hold it, just machine that. You're not gonna compete price wise or time wise or anything. And we've got a number of parts that you machine the base that isn't necessarily the actively cooled area, but it's got the connection points for the cooling. Print the business end of what you need to actively cool, and traditionally manufacture the rest of it, because that's what makes sense and that's what's going to keep your tooling cost reasonable.
Yep.
If you tried to print everything, then it's going to be astronomically expensive. But if you print the pieces that make sense and traditionally make the pieces that don't, then you can keep that more reasonable and you can do it more effectively.
And thank you for your time.
Thank you.
And to everybody
you.
out there watching, remember, for everything mold making, visit moldmakingtechnology.com.